Here's a very simple electronic toy I used to play as a kid, and even used to make it from a simple light bulb or buzzer and a battery. This version that we're going to make in this video, I made specifically for somebody's Christmas present. It was a kid's Christmas present. Hopefully they will enjoy this type of thing compared to all the games on their phones. This is very old-fashioned, traditional. My take on this one is slightly different. Instead of the buzzer sounding intermittently the moment you touch the wire, this one will trigger, and you have to go back to the beginning to reset. I'll give you an example. So we go around the wire. You're not supposed to touch it. And the moment you accidentally trip the wire, the eyes start flashing red and blue, and there's nothing you can do. Now you can't cheat. You have to go back to the beginning, and you touch this bar here, and it resets, which is great. And you can do it from the other side as well. So you can play from this side. Oh, go back to the beginning. Yeah, so that's what we'll make in this video. I used no microcontrollers. It's all old-fashioned analog electronics. Very simple circuit, and I'll do a diagram on exactly how it works. So here's my my simple circuit I came up with for the buzzwire game. It's based around this MOSFET transistor. It's a 2N7000, but you can use any MOSFET with a sensitive gate, logic level MOSFET. The battery for it is a lithium coin cell, CR2032. The gate of the MOSFET is connected to a capacitor and a 1 mega ohm resistor, and this creates a timer, so that when you touch the wire, you have to go back to the reset to reset the timer, in which case there's this sleeve here which is not connected to the wire, which the loop, if you touch it there, it discharges this capacitor. But if you touch the wire, the capacitor is charged and the gate is energized, which then through the 100 ohm resistor gives power to these two LEDs, which are connected in parallel. One is a flashing red, that's why the asterisk is, it has to be a flashing red LED, and the other one's a standard blue LED. There is another resistor which strictly is not necessary. This resistor is to limit the current to the buzzer so that it's not too loud. It's a piezo sounder with a built-in driver, so that if it has some power connected to it, it makes a beeping noise. An interesting thing happens when you connect a flashing LED in parallel with a blue LED. The forward voltage of a standard red LED is around 2 volts, and the forward voltage of a blue LED is around 3 volts. So whenever the red LED flashes, it shunts all the power away from the blue LED, because there's 2 volts across it, which is not enough to light the blue LED. But when the red LED turns off, the blue one will light. So they will alternately flash from left to right. This has another interesting effect, because the voltage goes up and down slightly, and the piezo buzzer is starved. It also has a slight effect on what the buzzer sounds like when these two alternate, which I find is an interesting feature, if you will, unintended feature, but I quite like the noise it makes. The other thing that happens as well is when this bleed resistor bleeds the capacitor and the time delay is finished, the voltage drops slowly, and then also the pitch is affected and the brightness of the LEDs is affected as it times out. And I only have shown one of these, but I've got another one of these sleeves, insulated sleeves, fitted to this side as well, just to make the diagram more simple. So you don't need any fancy microcontrollers or anything, just a transistor and a flashing LED. I printed off this little cat face, ready to stick onto a piece of wood. This is a wooden cap for a fence post, one I had spare. I quite like the shape, and I think I'll use this for the base. Collimatic lenses for eyes,
So you'll have nice scary flashy eyes. I put the LEDs in the back of the collimating lens. It's not stuck down yet, but I just thought I'd drill through his scary little eyes now. And, okay, they go in there, and collimating lenses will make the LEDs look quite nice once they're lit. They go in there, and what does that look like? Yeah, very good. One red, one blue, and then the sounder can sit nicely tucked in there like that, like that. And the lithium coin cell, CR2032. They can sit in there tucked in away, so there's enough stuff to put a bit of electronics in there to make it work. So I think it's fitting nicely. Just routed it out with my router.
So I traced out my kitty on a bit of paper, and I just need to bend the wire in quite the right shape, more or less. Doesn't have to be perfect as long as it's symmetrical. Just a few little tweaks here and there just to straighten the corners up. And I think also painted up the fence cap. Hollowed it out nicely with the router where all the bits are going to go. And wireframe kitty should go just in there. There we go. If we solder a wire either side, then if one breaks off, it still has a connection on the other side. Right, I think we need to epoxy this wire in so that you don't knock it and it pokes through either way or moves about. So just tack these wires back, and I think if I put this in with a bit of liquid epoxy glue, some araldite or something, some epoxy, and once that's glued in place, then I'll focus on putting the rest of the components in. So just mix up a bit of epoxy, just simple two-part epoxy. Try and get it in there. That should hold the wire in there firmly and keep the wires tacked down as well. So the epoxy at the bottom is set, not 100% yet, but good enough so we can continue work. So these tails here, which are not attached to here, what we're going to do is we're going to wrap some insulation. I'm going to use some of this heat-proof Captain tape, wrap it around this wire here, and then we can wrap foil tape on the top of that. And this is going to be our reset branch, so the loop would have to touch there to reset. So we need an insulation sleeve there. So I think what we're going to do is see if we can neatly wrap it with this now. So let's give that a try. So there we go. Now we can take some of this foil tape, which is copper foil, which we can solder onto. We're going to wrap it over the top of this. See how that goes. And then we could just leave it, or maybe tin it, or do something like that with a solder or something like that. Let's give that a try. See if we can tidy that up. Yeah, I think we can neatly solder that on there.
Just finishing off the last bit on this side of the Captain heatproof tape. Amazing stuff, this stuff. It can handle really high temperatures. And it looks just like ordinary cellophane sellotape. Right, so now we got an insulating layer which we can wrap some copper tape around. Right, so we've wrapped copper tape around this insulation first, copper tape. The wire is looped around the copper tape. I'm just going to solder that and then run solder to turn it all the way across. It keeps the copper tape together. And then we have the same as that. And then test for, see if the insulation is holding up, because these two need to be separated. Clean that up a bit. These sleeves here should now be connected to the black wire, I believe. Okay, give it a test with the meter. And we have no continuity, which is good. Perfect. Right, these eyes have been super glued in. Creates a bit of a strange effect on the lenses, but maybe it adds character to his eyes. I'm going to fit these 5mm LED that fits nicely in the collimating lens down there. The only problem I will have is I don't have a 5mm flashing red. I have a 3mm, but I don't think it will matter. The collimating lens will spread the light from the 3mm just fine. I need the one flashing LED because it's got the flasher chip in it. And there's a little trick where you can use one flashing LED to alternately flash two LEDs, as long as their forward voltage is different, so one takes over from the other one. So it's just positive to positive, negative to negative. But nicely at the bottom there. I think we should glue those LEDs in place. Use a bit of hot melt glue for that. So I think our alignment is not too bad. Yeah. So let's connect the positive of the sounder on there. There you go. See how that fits in there. Touch the resistor to drop the current to the LEDs. I'm just connecting the reset lines. Okay. So last but not least, we have to connect our little loop, wire loop. And that is simply one of these hooks screwed into a little piece of wood, attached to the wire, soldered to the tip there. And this is a piece of a wooden spoon from the kitchen that I just cut off, screwed it into there, and I've drilled a hole in the side. They will poke it in there. loop connected. And I think we'll test it, and then we'll put a bit of hot melt glue to secure everything. The battery should fit in there quite nicely. Yeah, everything fits. Bit of hot melt glue, or hot snot as some people call it. It'll help everything stay in place. There we go. The only thing left to do is to add a bit of the sticky back felt stuff to the base to finish it off. It acts as a cover for the battery, and it also protects the surface of where you put it onto. It's been a lot of fun making this this toy, and the only thing left to do now is to wrap it up and put it underneath the Christmas tree. Please leave a comment in the description if you want me to do anything else. That's a fun build for us to share on YouTube, and thanks for watching. I'll see you next time.